Hello, today we'll go through the first page of the acceleration questions. So there's two equations, change in velocity over time, and also the v squared minus u squared equals 2 times a times s. Before worrying about which equation to use though, the first thing to do is work out what the values are after we've boxed and underlined the key information. So the change in velocity is 10 meters per second. We've said the time taken is 5 seconds, and we're trying to calculate the acceleration. Now, when it comes to converting, well, we're in seconds, so that doesn't need converting, and we're in meters per second as well, so no conversion required there. Now we can decide what equation to use. So, because we've got change in velocity, time and acceleration, that leads us to this equation. Acceleration equals v minus u over t. As a reminder, v minus u, end velocity take away start velocity, that is the same as the change in velocity. So up here it says change in velocity, just means that number minus that number, v minus u, equals 10. So we've now got to substitute in the values. So we want to try and find the acceleration. So rather than change in velocity, we're going to write 10, and time is going to be 5. And that, of course, 10 divided by 5 gives us an answer of 2, and the units for acceleration, meters per second squared. So for the next one, we know the object starts at 8 meters per second, so that's a velocity, and it increases its velocity to 12 meters per second, and it takes 8 seconds, and we need to calculate the acceleration. So let's now write down the values that we know. So we'll check for any conversions, and again, no conversions to be had because all the units are standard. So u I've put as 8 because that's our start, and v, our end, I've put as 12. So now we need to choose the equation. Well, the equation, it's got u, v, t and a in, so the only equation is the same as the last one. So let's write that equation down again. And unlike last time where we were given the change in velocity, this time we've got the start and the end velocity, so we need to calculate the change ourselves. So we know that it was 12 minus 8 and then divided by 8. So sometimes we might need a bit more space than what I've given you. So 12 minus 8 gives us then 4 divided by 8. So then our final answer is 0.5, and we're still finding acceleration, so meters per second squared. Okay, for the next one, we know the car accelerates this time at 2 meters per second squared, and we've got a time, and we want to find the change in velocity. So let's write down what we know. We can now decide on any conversions, and again, like previously, no conversions required. So let's write down the equation. Well, it's got acceleration, time, and change in velocity in, so same equation as before, a equals v minus u over t. We can now substitute in the values. We know the acceleration is 2. Now v minus u, that's the same as the change in velocity, so that's what we're going to write on top. So I'm just going to leave that as a v, rather than civ for change in velocity, let's simplify it to v. And the time taken was 5. Now for the next part, we need to rearrange the equation. Now we've got a number divided by 5 that equals 2. So we now need to multiply 5 on this side to remove it, which means we multiply by 5 on this side. So it's 2 times 5 equals v. So therefore, the change in velocity is 10, and velocity is measured in meters per second. On to the next one. Again, we've got the acceleration given to us, we've got a time given to us, and we want to find the change in velocity. So same as before, let's write down the values of what we know. We know acceleration equals 4, we know time equals 3, and we want to find the change in velocity. I'm going to simplify that as v. So again, we've got acceleration, time, and velocity, so we use the same equation as before, and we're going to substitute in the numbers. So 4 equals v, but this time the time taken is 3. Because it's divided by 3, we need to multiply by 3 both sides. So 4 times 3, and that's then going to equal 12 meters per second. For the next one, we've got an object in space, and again it increases its velocity. This time it's 1 kilometre per second, so we need to be thinking about conversions as soon as you see kilometres. We want to find how long it accelerates for, so the time, if its acceleration is 10. So let's write down the values. So we've done that. We can now deal with the fact it's 1 kilometre. So for every kilometre, there's 1,000 metres. So 1 kilometre per second is the same as travelling 1,000 metres every second. We can decide again what the equation is that we're going to use. So we've got change in velocity, we've got acceleration in time. So again, same equation as before. And we can start substituting in the numbers again. So rather than a, we can write 10. And change in velocity is our 1,000 metres per second, and then that's divided by time that we're trying to find out. So we need it now, so it's time equals. So if time goes up here, and then the 10 comes down here, so they swap position. So then t equals 1,000 divided by 10. So then t equals 100 seconds. On to the final one on this page. So a stationary person increases their velocity to 3 metres per second. So the fact it's got the word stationary, that means the starting speed is 0, and then their end speed, v, is 3, and they accelerate at 1 metres per second squared, and we want to calculate the distance moved. So again, we're going to write down what we know. So u equals 0, v equals 3, a equals 1, and s we use for displacement or distance, and I've kept that as s because that's what we want to try and find. So this time we don't have time, so we need to think of a different equation, and that different equation is the other acceleration equation, v squared minus u squared equals 2 times 8 times s. So we're now going to start substituting in the numbers after we've checked to make sure there are no conversions required, and there aren't, so that bit's fine. So underneath the equation, let's write in the numbers. So 3 squared minus 0 squared equals 2 times 1 times s. Now I find it easier to simplify. So 3 squared turns to 9, take away 0 squared, so 0, leave that blank, equals 2 times 1, well that's just 2, and then times by s. So now we've got an equation where 9 equals 2 times s, and we're trying to find s. So because these are multiplied together, we need to get 2 on the other side, so the opposite of multiply is then divide. So 9 divided by 2 equals 4.5. And then a reminder, the units for distance or displacement is also metres. It's also worth just checking to make sure that that's right, so use that 4.5, 2 times our answer for s, does that equal 9? Yes it does, so we should be quite confident that that's correct.